In this video, I'm going to go over the Unit 3 test review. The first page is all graphs. Obviously, I would recommend using Desmos here. If you graph y equals 2 to the x, remember you can always click the setting and get a table from that if you want some good points to plot. So 0, 1, 1, 2, and 2, 4 would all be good points to plot there. If you have a graphing calculator, there shouldn't be any reason why your graph is not accurate. On these, you're going to be asked to find domain, range, and asymptote. With all exponential functions, the domain is all real numbers. So for both of those, it's all real numbers. You can find the range and the asymptote from your graph. The asymptote is for an exponential graph, there's a horizontal asymptote. It's leveling off at 0, right? So it's never crossing the x-axis. So the horizontal asymptote would be y equals 0. And whatever that number is, that's where your range, the entire graph is above that. So our range would be that y is greater than 0. If you have a vertical shift, and I'll just do that with this first one. So if I had 2 to the x, and let's say I had a vertical shift of plus 1 here. Notice what's going to happen here is it's going to move that up 1. And now I can see that there would be a horizontal asymptote there at y equals 1. And we're approaching 1 as we go off to the left forever there. So whatever that vertical shift is, and again, you should be able to see it from Desmos, that is going to be your asymptote. So here it would be y equals 1, and then our range would be that y is greater than 1. Okay, so those two things are related. Get your graph from Desmos. Shouldn't be any reason why you don't have that graphed correctly. With logs, those things kind of switch. So the vertical asymptote, it's now a vertical asymptote instead of a horizontal asymptote. The range is now all real numbers. And so the domain is going to be affected by the asymptote, right? So all parent functions of logs, which is what's graphed here, this would just be log base 2 of x in both cases here. The parent functions have a vertical asymptote at 0, at x equals 0. Well, if there's a left or right shift, so this minus 1 here is a shift to the right. So essentially it's going to take every point. We're going to go right 1 and down 1. And that's going to happen to every point. Now again, I can use Desmos to help me get this, but the idea is there's my graph based on the shifts. My vertical asymptote that was at 0 has now been shifted to the right 1 because of that minus 1 there. So our asymptote is at x equals 1, and our domain is that x has to be greater than 1. With this one, we got to shift to the left 3, so our asymptote is going to be at x equals -3, and the domain would be x is greater than -3. And again, all of that would be able to be seen from Desmos if graphed correctly, and you examine the graph a little bit, you should be able to see that. While I'm talking about that, 7 and 8, when we're finding the domain of logs, it's kind of the same exact thing that you're doing up here, right? So what would the domain of this logarithm be? Well, it's x is greater than 1, and really what it is whatever's inside that, you can't have negatives inside of a logarithm. So I take whatever the expression is, and I say, oh, that has to be greater than 0, and then I solve, so x would be greater than 1. Matches up with what I have there. So that's what I'm going to do on these. I'm just going to take the expression that's inside the log and say that it has to be positive. And if you solve that, in this case, you would get x is less than 1/5. You would get less than because you would be dividing by a negative, which would result in flipping the inequality. But then in interval notation, that would be negative infinity to 1/5. So I do that. But what I would recommend is that you actually just graph this. So if I graph y equals log of 1 minus 5x, obviously it's to the left this time instead to the right. But my goal is to just figure out what this vertical asymptote is. So what is the line that my graph is approaching? And I can kind of see that it's at 0.2, right? So at 0.2, we see that, you can still see 0.2, your graph is getting closer and closer to 0.2. Well, 0.2 is 1/5. That's where that comes from. And why it's negative infinity to that, or x is less than that, is because the graph is to the left of that line. Okay, so I'd recommend doing that. And I would do that on the next one as well. So it's just log of x squared minus 9. And on this one, you can clearly see there's two different regions. the asymptotes are at 3 and at -3. So it's either greater than 3 or it's less than -3, right? So that's how I'd write that, but in interval notation, I would have negative infinity to -3 and also 3 to infinity. I would just use the graphs to help you with that. Okay. The most important part of this test, as I've mentioned, is being able to go from log form to exponential form. So if we had log base b of x equals y, that means that b to the power y equals x. That's the most important thing that you know. So that's what we're doing here. The first thing I'd want to do when I'm using definition of a logarithm, I'm essentially using this idea of switching it to exponential form. So I'm going to go 2 to the power x equals 1 over 32. And I'm just trying to figure out what that power would be. So x to the 5th power is 32, but if it's on the bottom, that means I had to have a negative exponent because negative exponents send things to the denominator. So our answer there is -5. Yes, you could just plug this into Desmos to get that. Okay, and then on number 6, the reason that I made this the way it is that you have to know this idea, this concept. So we're going to go base, which is a, to the power 2 equals what's inside, which is x. The goal is to solve for x, and we've got that by itself. X is equal to a squared. Okay, so there's nothing I can do there. I don't need to use a calculator. I can't use a calculator for that. On this one you could, but again, it's kind of the idea of what does that mean? What am I actually solving for? Why is that -5? And that's kind of the idea there. I'm going to jump down to 9 through 12. These are just your log properties. If you have multiplication, if you're expanding and it's multiplication, you separate that out using addition. So we're going to go log base 7 of a to the 3rd plus log base 7 of b to the 5th. And then if you have exponents, those have to come out front as coefficients. So we're going to go 3 log base 7 of a plus 5 log base 7 of b. I think you could probably do that in one step, and I really don't need to see the intermediate step there, but if you need to, go ahead and do the intermediate step. On number 10, the first thing you'd want to do is bring that exponent in, and if you did that, that would be u to the 10th, and that would be v squared. But then we're going to do kind of the same thing. If it's division, it's just subtraction instead of addition. So we're going to go 10 log base 7 of u minus 2 log base 7 of v. And that's going to be your final answer there. Okay, so 11 and 12, you're doing the opposite. We're condensing this down to a single logarithm. So you should only write log one time. If you're writing log more than once, then you are doing something wrong. So I would just start with write log base whatever it is, put parentheses. I know that I'm not writing log more than that. Okay. If it's addition, it's multiplication, and then any numbers that are out front come up as exponents for that one only. So I would have x times y times z squared. And then on this one, we bring the 4 up, we bring the 5 up, so we have u to the 4th divided by, subtraction, v to the 5th. That's all we need to do on those. This page is probably the most important, the solving equations. Again, I'll write this down, but this is the number one thing. Log base b of x equals y means that b to the y equals x. It's very important. If you have an exponential equation, which is what we have on 13 through 16, the variables are in the exponent. The first thing you need to do is isolate on one side the exponential part. So that's done on 13 and 14. On 15, the exponent's on the e, so I need to get rid of the 3 first. I'm going to divide by 3. It's now e to the x plus 3 equals 9. On number 16, I need to divide by -4. So it's now 8 to the 2n power equals 20. So you need to isolate that first if you have that step. So 13 and 14, I don't have to do that. 15 and 16, I do. Once you do that, you're going to rewrite it in log form. So we're dealing with this. We're going to go back to log form. So the way you do that is we're just going to go log base 16 of 64 equals the exponent, which is 2b. And I could do that on every single one of these. Log base 27 of 243 equals 2x, right? After you go to log form, you still need to solve for the variable. So in both of these cases, I would just divide by 2. Make sure that you're not just dividing the 64 by 2. Okay, this is not 32. It's all of that, log base 16 of 64, divided by 2. Just plug all that into the calculator. Same thing on this one, divide by 2, plug all that into the calculator, and you'll have your answer for x. On 15, you would do log base e of 9 equals x plus 3. Log base e is the same as natural log ln. So if you just want to do natural log of 9, you can do that. Desmos will let you plug in log base 9 if you want to do that. But anyway, if I want to get x by itself, I just subtract 3. So I would do all of that minus 3. There's your answer. On this one, we would do log base 8 of 20 equals 2n, divide by 2, divide by 2. There's your answer. Okay. 17 through 20, you're doing log equations. We're going to essentially do the opposite. We're going to go back to exponential equation. On 17, I've got a shortcut. If both sides are log of the same base, I can just ignore that. I can solve 4k minus 4 equals 2k and solve that for k. That only works if both sides of the equation are just a single log of that same base. I can't do that on 18, 19, or 20. I don't have any logs on the right side on any of those, so I can't do that. So your goal on these is take the left side, use your log properties to condense to a single log. So this would be division because it's subtraction there. Okay. And then we're going to rewrite this as in the exponential form. So the exponential form would say this to this power. So I'm going to go 3 to the third power. And I just like to have my x on the left side, so I'm right over here, equals the stuff inside. So 4x over 10. And to solve that, we would just do 3 to the third. We'd multiply by 10, divide by 4, and we'd have x by itself. Okay, and that's the task every time. So take this, use your log property, log base 9 of, it's addition, so we would do multiplication. X minus 10 times 2 would be 2x minus 20 equals 1. Rewrite it in log form, so we're going to go 9 to the first power equals the stuff inside, 2x minus 20, add 20, divide by 2, and so forth. And then 20, again, the same thing. So we're going to go log base 3 of x squared plus 8 divided by 4, because it's subtraction, equals 3. X squared plus 8 over 4 equals 3 to the third power. Do 3 to the third, multiply by 4, subtract 8, and take the square root. If you do all that, so if 3 to the third is 27, if I multiply by 4, it's going to give me 108. And then if I subtract 8, I'd get 100. So I'd have x squared equals 100. When I take the square root of that, make sure you put plus or minus 10. Anytime you get more than one answer, you should probably check them. And really, all that you need to make sure is that in any single logarithm, you don't have a negative number when you plug that in. So it doesn't mean that negative 10 is wrong, but I would want to check to make sure that if I plug in negative 10 for that x, that all of that together is not negative. And it wouldn't be. I would get 108, so it's fine. Both of these are answers, negative 10 and positive 10. But if you do get negative answers, I would go through that process of kind of checking that. All right, last two questions are interest formulas. I'll give you these formulas, but we've got this one, which is compounded interest formula. Principal rate. The principal is the amount that we plug in, which is 5,000. The rate is that percentage, but I wouldn't need to put that in as a decimal, so 12% would be 0.12. The n is the number of times compounded per year, so that's what's changing. So compounded annually, quarterly, or monthly, the n is what's changing. So I'm going to leave that as n. And then this would be n times 8 because it's after 8 years. What I would suggest is plugging this into Desmos as is with those n's in place of where they go there, instead of plugging the numbers in there. And then if you do that, it'll ask if you want to add a slider. So I'll show you what that looks like really quickly. So if I did 5,000 parentheses 1 plus my rate is 0.12. If I just put an n down here, notice how that came up, add slider n. My exponent is n times 8. I would recommend putting that in parentheses. Otherwise it might bring your plus or your times 8 down here, which we don't want. We want it in the exponent. If I just do this add slider n, it's going to allow me here to just change the value of n. So if n is 1, this is what I get, $12,379.82. That would be the answer to part A, because if it's compounded annually, that means that it's compounded once per year. So that would be n equals 1, quarterly would be n equals 4, and monthly would be n equals 12. And in Desmos, I can just go in and I can change that 1 to a 4 or a 12 or whatever I want that number to be, and it's going to update my answer as I do that. You don't have to do it that way. It's probably just the quickest way to get those. Anytime you see continuously compounded, that is the PERT formula, PE to the RT. The principal amount is still what you invest. E is just the mathematical constant E. There's no number to plug in there. The rate is 7%, so that would be 0.07. And the time is what I'm trying to find. How long does it take? So I'm trying to find time. We want our initial investment to be doubled, so we want this to equal twice the initial investment, which would be $25,000. So to solve this, we would divide by the 12,500. Shortcut here is that's going to be 2, and the reason I know that is because I wanted my investment to double, so it's going to be twice whatever we started with. We get to that point, it's an exponential equation, so I need to rewrite it in log form. So we're going to go log base e of 2 equals the exponent, which is 0.07t, and then we would divide by 0.07, and I could plug that in the calculator, and that would give me my time. Okay, if you have any questions, come see me. It's just a quick overview of the test.